this particular class, I will discuss the different doubts that you have asked to me and the different numericals in which you are slightly getting problem and getting difficulties. In that regard, I am first taking the question that you have sent to me in which you have doubt. This is the question of DC Pandey that you have asked to me. See the question first. We are observing here that the field intensity is equal to alpha xi, where alpha is constant. This indicates that the field intensity depends upon the distance x. The values are also given to us. This means that as we are proceeding from the origin, the field intensity will vary. So we are first supposing here that the field intensity starts from origin and it forwarded in this direction like this. So first, what will be the field intensity when it will interact the face ABCD? So ABCD, if we take the area vector on it, that area vector will proceed along this direction. Let the area is S, dimension is L, that's why it will be L square. Area is L square. The field intensity is proceeding in this direction. That means the flux entering at this space is phi 1, that is equal to E1 dot S, that is area vector. So it will be alpha, and at a distance, this one is L, so x is equal to L, its vector will be I cap, and this one is L square, and it is also directing along I cap. This means I dot I is 1, so it is alpha L to the power q. You may write I dot I should be 1, so it is alpha q when it is entering. Now the same field intensity will interact at this phase. The flux will exit, the flux will come out of the area EFGH. So when you are taking the phase EFGH, the area vector will act along this direction. The field intensity is also in that direction. So you can calculate the flux exiting from that phase. Now at this particular place, the field intensity will become alpha, which is 2L I cap, and your area vector will be L square I cap. That means it will be 2 alpha L square. So this is net entering at this phase and this is net exiting at this phase. If anybody asks you to find out the net flux enclosed within the tube, what will you do? You will take the change of flux, del phi. Remember that the field intensity starts from this particular place at a particular distance, at this particular stage, or at this particular phase. The field intensity will be equal to this much. At this particular phase, field intensity will be this particular value because it depends on x. If the value of alpha is also given to you, you can substitute that part. So net flux means total flux entering minus total flux exiting, or total flux exiting minus total flux entering. So it is phi 2 minus phi 1. You can subtract these two values. You will get the net flux enclosed within it. Now, if anybody asks you to find out the flux, but remember here that this particular field intensity is only propagating along x-axis. So it will not have any flux along this particular area or this particular area. For this particular reason, you may take any particular cube to understand it clearly. For example, like this one is a cube, it is acting along x, this one is y, and this is coming towards you, that is z. So this is z, this is y, and this is x. This means this one is yz plane. So this will be x and z. So this is x z plane. If this one is y, this one will also be y. If this one is xz plane, this one will also be xz plane. And what about this one? This is xy plane. So this particular phase, this one is xy plane. So remember it that this phase and that one, this is also xy plane. Flux basically means that the field intensity must be perpendicular. The flux basically, you know that the electric field lines which pass through the surface normally. This means when you are taking yz, the flux is coming from this particular part. So in this particular yz plane, the flux will come along area vector normal to area. So it will come along I cap along x-axis. This one is xz plane. That means its area vector will be along j cap. This one is xy plane. That means its area vector will act along z, that is k cap. So remember that with the field intensity is propagating along x-axis, it will make the flux only through yz plane, this ABCD, and through EFGH. Right? So net flux is equal to this much. If anybody asks you how much charge is being enclosed within it, then you know the formula. Net flux is equal to total charge enclosed by epsilon naught. This value will come here. If you multiply with epsilon naught, then that will become the charge enclosed within it if the free space is there. Now, in any other question, you can be asked that this particular origin or the field intensity starts from this particular place. That means this origin is shifted here, right? So in that particular case, if this origin or the starting point of field intensity is somewhere here, you can see the flux entering equal to 0 because it starts from this particular place. So it will only forward in the forward direction, in the positive x direction. This means the flux through this particular portion becomes 0. So your phi1 is 0. You have to calculate only flux through this particular portion. But remember, still field intensity is acting along x-axis. So phi2, in that particular, you have to calculate with the same method that it will start from this particular place. What will the field intensity here? Now, this is area vector, so multiply it with that. I don't think there will be any problem if you want to calculate the field intensity here, because field intensity at this particular point will be alpha. This one is L. If it starts from this particular place, alpha L into I cap, and your area vector becomes Li I cap. So this becomes only alpha L cube. This is the flux exiting from the face, and this will remain as the net flux also. This will also remain same here. Now, if in the third question, frame is same, only you are changing the mode of operation. If the axis in this particular question, the second question was here. Now, in the third question, you are being asked that the origin is somewhere here. That means field intensity starting from this particular point, which is inside. First time it is outside the cube, second time it is on the face, and third time it is inside. Then what will you do? Nothing worried about it. If it is inside, now it will move along two directions. One it is forwarding, another along this direction. So when it is moving along this direction, in the same manner, you will take the field intensity here at a particular distance, multiply it with this area vector. When you are taking along this direction, your area vector will be along this direction. Similarly, you will find out the field intensity at this particular place using your variation of dimension or the distances and multiply it with area vector. Now, in both the faces, the flux are coming out. This means the net flux coming out will be equal to phi 2 plus phi 1. So this becomes the net flux coming out through this particular. In this way, you can solve three different types of questions. Now, in the same way, I can also change that. If the field intensity in some other question is acting along three different directions, suppose it is 2i plus 3j plus 6k. Now you are observing that it is not in the same way which we have solved. So from this particular question, I have cited you the three different types of examples. In this case, field intensity is acting along x-axis, along y-axis as well as z-axis. If you are being asked to find out the flux from this portion, then the area vector will act along I cap. So this particular field intensity will propagate along x, y and z in all the three axes, but it will give the flux with only this component of the field intensity, not by this and this, because if you will take this one and this one, the field intensity and the area vector will not equal to each other. So remember that if this field intensity is given and you are being asked to find out the flux through yz, then you have to multiply with 2i and I cap. If you are being asked to find out the flux through xz, this time flux will be there because xz plane will have area vector acting along j cap and j cap is present here. So this particular component multiplied with this area vector will give you the flux moving from xz plane, this one and this one. Similarly, in this particular question, flux will come out through xy plane also, because xy plane will have its vector along k cap and the component is here. So very simple to calculate, but remember that if it is given only along x-axis, field intensity is acting on x-axis, then you can find out the flux only through this particular portion yz and this yz, not along xz and xy. But if the field intensity is given along all the three axes, you have the flux through all the three different types.